Okay. We are recording. So, Tadi, you can take it away and talk to us about scaling some serverless things.
Thanks, Ryan. I'll just quickly share a screen.
Yes. And while I do that, so we are recording this and it will be uploaded to our YouTube channel. I'll share the link in the chat if you don't have it. And then we also have a Twitter. I post there when we have meetups, and then to my LinkedIn, and sometimes to the ZTech Slack in the announcement channel. Are you sharing?
Yeah, can you see my screen?
No, we just see a big T. Well, I see a T.
Let me just try and put that into title again. Can you see it now?
Oh no, still not. Strange because we tested it this like 15 minutes ago.
Very strange.
Maybe just stop completely and then try it again.
Okay. Cool. Let's give this another go.
Wow, why not? Yes. We're showing it.
Perfect.
Awesome.
Okay, thanks. Thanks, Rayan. Thanks for hosting, Rayan, and setting up the meet. So, hi, my name is Tadiwa Mazara, and I am a serverless developer at Aleios. You can catch me on LinkedIn if you want to send a DM if anything on this talk interests you. At Aleios, we work on greenfield and brownfield projects, mainly using the best of serverless whilst following industry's best practices. Cool. So I'm going to get into the talk for today. We're going to be looking at scaling serverless architectures. And the goal of this talk is mainly to get us in the mindset of what we need to consider when we speak about scaling. So what we'll be covering is mainly API Gateway, Lambda, and DynamoDB. And this is like the backbone of any serverless architecture. You'd normally find at least one or two of these services at play, especially AWS Lambda. Cool. So the first question starts before we even get into how we scale serverless architectures is why is scaling important? I think the main 3 points that I picked up were to improve user experience, ensure high availability, and enhance cost efficiency. So if I just double down on improving user experience, imagine you're using a site, it could be an e-commerce site, and maybe it's Black Friday. Let's say it's Black Friday, everyone's going mad, everyone's shopping, and you're searching for that favorite gadget that you've been wanting to buy all this while, and you click that button and boom, nothing happens. The service is not available. That's indicative of a scaling issue, and now raises the importance of scaling. Also, when you speak about high availability, as we're designing systems, we want to design systems that are fault tolerant. So let's just say, for instance, you've spun up or you've deployed your application and something goes wrong, or maybe a region goes down in the cloud, and that's where all of your resources are. And if that region goes down, it means that your application is down and your customers can't access your application. So these are some of the things we need to consider when we are talking about scaling. And lastly, is on cost efficiency. So if you've got a SaaS or a software as a service, you want to make sure that your costs are kept quite low. That also sort of helps the probability of the business So you want to make sure that as you're scaling up, as you're gaining more users, it is important to consider how your costs are also ramping up and what measures you can take to keep your costs at a minimal. Cool. So some of the key considerations that we have when we're dealing with managed services like in AWS is looking at the service limits. Essentially, when we're creating serverless architectures, we're putting together all these different types of managed services. And all of these managed services have different constraints. They have timeouts, they have retry behaviors, they have limits on throughput and payload size. So for instance, an AWS Lambda function can only run for a maximum of 15 minutes. So if you are running some operations that are taking more than 15 minutes, then maybe it might not be ideal to use AWS Lambda for that. Or it might be, we might need to consider how best we can sort of shift our workloads so that they suit a serverless architecture. And one of the main considerations as well is almost to sort of put on that architectural hat as you're designing a serverless architecture. You want to be able to take a step back at your architecture, see how you've set up all of these managed services, and ask yourself the question, have I as an architect or have I as a software engineer, or are we as a team working on a architecture that enables us to scale, that enables us to meet our users' demands? So these are some of the considerations that we need to make when we're designing scaling serverless architectures. Cool. So we're going to start off with API gateway. So API gateway normally is the front door of your application. All traffic normally would firstly enter your application through API gateway. So we want to focus on this piece first and look at the different things that we can do with API gateway in order to help us build a scaling application. Cool. So firstly, we don't simply create an API. We have to take so many things into consideration before creating an API. So usually you have two cases. You might be creating an API for a brand new application and you have no idea what sort of traffic you can expect. And there's another case where you might be creating an application, where you might be creating an API for an existing app. So maybe you're migrating from one architecture to the other, and you've got a feeling for what sort of traffic you expect your application to be handling. While you're looking at, if it's the case of an existing application, you might want to consider where your users are trying to access your API from. You might also want to consider how often they're accessing your API, how frequent are their requests, and you might want to also look at if they're making any API calls that might be affecting downstream services. Another thing to look at is like the cost. Like what is the cost of access? Are there any corners that you can perhaps cut to save on costs and not affect user experience? So API Gateway has a couple of features that are relevant to scaling. The first would be edge optimized endpoints. So these would be for APIs that are being accessed globally from different locations in the world. So you can imagine if you've got traffic coming from Australia, you've got some traffic coming from the US, you've got people making payments from Brazil, India, and some maybe also in South Africa as well. So maybe if you've got traffic coming from all these different parts of the world, you might want to consider putting a CloudFront distribution in front of your API gateway, and that way you can cater for your customers optimally and in a performant manner. Another thing that we might want to consider as well is caching. So for instance, imagine you are running an e-commerce site and you've got so many users coming in and viewing items on your e-commerce site. And these items are not changing in terms of like details. So the details of these items and the pricing maybe is consistent for 2 weeks or a month. You might want to be able to cache all of these calls at the API gateway so that you don't make the extra API call to your database. So this is one option that API gateway can also provide. And let's look at the other option where you've got perhaps malicious users. Maybe perhaps you've built a third-party API and you've availed that to some users and you've provided them with some API keys, and then you start noticing that maybe there's someone who keeps hitting the same endpoint on your API, and then this is putting a load on your system and your costs are ballooning. You're trying to make a profit as a business. Maybe this is you starting your software as a service app, and you see all of these things ballooning. So some of the options that you have with API Gateway is to create API keys and usage plans, and you can then restrict the amount of requests that a user can make per second. And lastly, also relevant to API Gateway is the extended timeouts. So this is more important if you're looking at how it integrates with other services. I think currently the default or the set timeout for API Gateway was around 29 seconds. And this timeout has now been increased. So this is some of the things that we need to look at when we're looking at scaling an API Gateway. Cool, I'm just gonna go to the next slide. Cool, so I'm just gonna jump into an example. It uses a more advanced feature of API Gateway. So this is called a Lambda authorizer. So pretty much what a Lambda authorizer does is that it's able to do the authentication. It's able to process the authentication logic for your application. So instead of having API Gateway integrate maybe with something like Cognito, this Lambda authorizer can maybe integrate with a third-party service like Auth0, and you can have you have this Lambda that then processes that authentication logic. And what tends to what my experience working with this authorizer pattern was that when you're working with these Lambdas in an authorizer pattern, you sometimes firstly get called start times. So it might be quite slow. Maybe your traffic is not consistent. And the second thing is that you might end up making an API call to a third-party service frequently when you don't need to. So one of the ways to get around that for an authorizer is to use what we call, we can use caching for the authorizer. So this is mainly telling the authorizer to like cache the result or save the result of an execution. So let's just say I'm user A, I've hit your API and you're using a custom authorizer, and your authorizer initially has allowed me to access the API. When I do make a subsequent API call again to your API, the result of that authorization action has been saved on API Gateway so that your authorizer Lambda doesn't have to make a call again or do a computation to allow you to access the API. And this is something that you can potentially do to save on costs and also ensure that your users get a better experience as there's less time and due to no computation being made. In this example, this is a cache that's been made that caches the result of an API key for about 30 minutes. So if a user has provided an API key to access an API, and they've done that successfully. That result is cached for 30 minutes, and it prevents any further executions if they do decide to make a call to the API. Cool. Any questions so far before we move on to the next thing? Cool.
I think that's fine.
Cool. I'll take the silence as a no. Cool. So the next part we want to step into is AWS Lambda. AWS Lambda is Amazon's serverless compute service. So it allows you to do computations automatically without managing infrastructure, and also without provisioning any capacity. It does this all under the hood. So in dealing with Lambda, one of the things that is important to consider when dealing with scaling as well is concurrency and memory. So you might want to ask, what is concurrency? What is memory? Cool. So I'll start on concurrency. So concurrency is the number of in-flight requests that a Lambda function can process at the same time. So for instance, to gain a better understanding of concurrency, we'd have to look at the AWS Lambda execution model. And usually for your Lambda has 3 phases when you're executing it. The first phase is the initialization phase, where all of your dependencies for your function are initialized. The second phase is the invocation phase, where your Lambda function actually does the work, does the computation. And then the third phase is the shutdown phase. Your Lambda function has completed execution and shuts down, so that kills that resource. So in this case, I have an example, a depiction of one request. And you can see when the create request arrives, we first hit that initialization phase of the Lambda. And then we go into the invocation phase where the actual computation has been done. And at this point, the execution environment or that instance of the Lambda function is busy. So what happens if one of our users makes a request at this particular time? We've got one instance of a Lambda that's doing some work, and another request comes in. What actually happens? So to further explain that case, I have an example with 10 requests. Cool. So I've got 10 requests in this example, and 5, and so I'll just step through each and every request. So if I go into request number 1, is made to your application or to your Lambda function. Your Lambda function is in its initialization phase at this point, and request number 2 comes in. So when request number 2 comes in, it checks, okay, cool, there's a Lambda function that's available. There's an instance of a Lambda function that's currently here, but it's busy right now. So Lambda automatically then spins up another instance of your Lambda function to cater for request number 2. And if request number 3 comes in, whilst request number 2 and number 1 are also processing, another instance of a Lambda function is created. Subsequently, this happens for request 4 and request 5. Cool. So let's say request number 6 comes in, and we've got request 1, 2, 3, which have completed execution at this point. When request 6 comes in, it uses the same instance that was of a Lambda function that was used by request number 1. And when 7 comes in, because these two are free. 7 uses the instance that was used by 2. And similarly for 8, 9, and 10, when these invocations are free. Cool. So you're dealing with your application. You have you sort of now know how concurrency works, but like how do you compute this? How do you calculate it? How do you do like a back of the envelope like calculation for your application? Maybe you've been given that your application receives like 500 requests per second. How do you get a feel for the concurrency? And the importance of this is because AWS Lambda has a limit for concurrency. This pattern previously shown doesn't go on and on. There's a point in time where this stops. So for most, by default, this limit is up to 1,000 concurrent executions of AWS Lambda per region. So we'll get into some calculations, and yeah, it's very late. We don't want to be doing maths right now, but I'll step through it quickly. So your concurrency is pretty much a calculation of your average requests per second and the duration that your Lambda function runs for. So let's use some examples to get this formula alive so we can get a feeling for the formula. Cool. Let's look at a scenario where we've got 200 requests per second that are being made to your application. So let's imagine that's going through your API gateway. You're having 200 requests per second hitting a Lambda function. And let's say the duration of your function is 1 second. So let's have a feeling. Let's try and do a calculation and sort of calculate what our concurrency is and sort of question ourselves, are we not hitting that limit that AWS has set, which is at 1,000? So for this case, it's 200. 200 times 1 would get a concurrency of about 200. So we can safely assume that we're not going to get any requests that are going to be throttled because of that concurrency limit. So this would be safe if we're handling 200 requests per second. If we were to perhaps say increase the request per second to 1,200 and the same duration of execution for our Lambda function was maintained, then we would see that limit being hit that AWS has, which is at 1,000. Cool. So let's jump into a second scenario. Okay, so in scenario 2, we've got 200 requests, and each function is now more performant. You've got a Lambda function that's quite quick now, and it takes 50 milliseconds to process, so 0.05 seconds. If we use our formula, and yeah, this might be not the most friendly mental math calculation, but I've done it beforehand for you. We'll get a concurrency of 10. So we sort of get that feeling that it's 10 if we use a formula. And is this answer quite right? If someone has a calculator close by, you can punch these numbers in. So we get an answer of 10. Cool. And the answer to that is that no. Your concurrency for functions that are that execute in less than 100 milliseconds has a limit. So your concurrency at this point won't be 10. What your concurrency is actually in this instance is 20, and I'll explain why. Each Lambda function, when reused, can only process up to 10 requests per second. So this is the equivalent of a request taking 100 milliseconds. So for any requests that are processed by a Lambda function, and your Lambda function takes less than 100 milliseconds, AWS Lambda will limit the potential of further executions. So for this case, your concurrency will remain at, your concurrency will be determined by that limit. And using that 100 milliseconds as your duration, your concurrency will come out as 20. Cool. So This is just to summarize so far where we're at. We've talked about concurrency. We've talked about concurrency and the calculation of concurrency. Cool. So let's say you have your application and you've got some critical functions that you want to always run. You don't want these functions to be stopped at any point, or you want to ensure that these functions have a certain capacity to run. They have a certain concurrency that they have at any given time. And with an example where you've got 1,000 concurrent instances as your maximum, and you've got two functions, blue and orange, which you can then reserve concurrency for in order for them to be guaranteed enough capacity to run without being throttled. So if I look into the orange function, as we step through the orange function, as we go through in our applications over time, people are making requests. We've reserved 400 units of concurrency for our function. And if it goes past that 400, it gets throttled. And that's the red line that you see there. And then over time, if it decreases, the throttling stops and all of the processes, all of the computation that your function is carrying out goes through. If you look at the blue function, which also has a reserved concurrency of about 400, this one stays within the bounds of the reserved concurrency has been given, so it's able to freely execute whilst handling all of your users' traffic. And let's say you've got other functions, other Lambda functions that you haven't reserved any concurrency for. These functions use the remainder of the concurrency left in the account. So for instance, in this case, the remainder of the functions will use the remaining 200 units of concurrency within your account. Cool. So next, I'll step into provision concurrency and why it's important for scaling your serverless applications. So for instance, provision concurrency is important in terms of ensuring that your Lambdas don't go through the initialization phase, so that your Lambdas are already prepared to execute. And this might be critical if you're running time-critical loads, or you want to increase performance for certain functions, for certain Lambda functions. You can do so by providing by provisioning concurrency beforehand. So this keeps your Lambda warm, and when your first request comes in, it doesn't have to go through the initialization phase. It simply is processed by an already waiting function, a function that's gone through the initialization phase and waiting to process a request. And subsequently, if you have a second request, the same occurs again. There's an instance or an invocation or an environment of a Lambda function that's waiting to process your request. Cool. I guess this covers the concurrency part. So the next setting that we want to look at for your Lambda functions is memory. So memory is the amount of power or the amount of RAM that's allocated to your Lambda function. It determines the performance to some extent of your Lambda function. Cool. And to sort of help us determine how we choose or configure our memory, I'm just going to show you a quick demo on Lambda power tuning. So I will just step out here. Cool. So on serverless repo on AWS, there's a tool called AWS Power Tuning. It's open source, free to use for everyone. And what this application does is that it helps you select or configure your function, your Lambda functions. It's pretty easy to install. So if you were to access it on this link, and if you click the deploy button, all of this application will be deployed into your AWS account, and then you can freely use this application. I won't step into too much on how it works. I'll just tell you under the hood that it uses AWS step functions. You can provide it with certain inputs to sort of choose your memory settings. So in this case, for this example here, you can give your function power values of 128 megabytes up to 3 gig. So what this tool does is that it goes through your selected Lambda function and then makes invocations makes certain number of invocations for different memory sizes. You can choose a strategy that you can use for this. One strategy that you can use is cost. So if you want to minimize on cost for your Lambda functions, you can select the strategy. Cool. So I'll just show you some of the code that I have. So I've got a basic project made using CDK, and it contains a Lambda function that calculates the Fibonacci of a given number. And what I did is this: I've already deployed this stack, and this is the Lambda function. So we want to be able to select the memory for this function. Like how do we know the best memory to configure for this function while saving on costs? Cool. So I'll hover into the AWS console. Once you've clicked deploy and installed this application into your console, you'll see something under applications in your Lambda dashboard. And if I click there, you see that it's been successfully deployed. I deployed this quite some time ago. Cool. So how does this tool work? So what I'm going to do is I'm going to target this Lambda function, which contains this code, which calculates the Fibonacci of the 25th Fibonacci number. And what I'll do is I'm just going to quickly copy what they have here as an input, and I'm going to go into the application, and I will start an execution of this application. So it's going to try out these different memory sizes. It's going to try and do 10 times for each Lambda. It'll do it in parallel so that's quick, and it's looking for the cost. All I need to do is copy the function's Amazon resource number. So I will go to the Lambda function, and I'll copy the ARN, and I will paste it in here, and I will click start. Cool. So this is currently in progress and currently running. And I will sort of view the step function workflow as it runs. Cool. You can see it's making progress. Should be pretty quick. Cool. Seems like it's done. So we'll just click on the optimizer here where the final results are contained. And I will scroll down and you will get a nice link, which is this link here. I'll copy this link, paste it in this tab, and let's see what we have. Okay, cool. So here we get a graph, which sort of breaks down what the cost would be and what the time a Lambda function would take for calculating the 25th Fibonacci number. So we can almost see as we scroll through this graph and we try and find a sweet spot. So you can see the best cost is at 512 megs. And the best time, if you're looking for a fast execution, is at 3 megs. And it's also given you the worst and the best. And if you want to gain a more finer, if you want a more fine-grained memory size, you can always edit it in the inputs that we initially put into this power tuning execution. Cool. So in this case, if I wanted to save costs and I still wanted to execute it at an acceptable time, I would choose 512 as my memory setting for my Lambda function. Sweet. Cool. I'm just going to step quickly through the last bits in the interest of time. Cool. So I'm going to look at quickly at DynamoDB. So DynamoDB is Amazon's NoSQL database. When we're talking about scaling, we probably want to look at its 2 operational modes, which are on-demand and provisioned. So for on-demand, it pretty much scales based on the previous peak of traffic that you'd have received on your database. Usually what DynamoDB does on demand is that if you surpass it can provide you enough capacity to read and to make read and writes to your database that are twice as much as your peak. If you exceed your peak within 30 minutes, it might throttle your request. DynamoDB also has something called adaptive capacity when working at scale. So if you've got a certain partition of your database that's being consistently hit, it's able to allocate more resources so that that partition can better service your customers. Another operational mode of DynamoDB is the provision mode, where you can configure the amount of capacity, which are your read capacity units and your write capacity units beforehand. What this means that if you do provision these and requests are made to your table that require more capacity, your requests are throttled. So those requests then fail. If you've provisioned capacity, we need to be aware that it is billed per hour. So even if you don't use that capacity, it will be charged against your account. Sweet. Yeah, that brings me to the end of the talk. Just wondering if there are any questions and if there are any experiences with people dealing with scaling serverless architectures. Thanks.
Hey, Tadiwa, how's it going?
Hi, how are you doing?
I'm good, thanks. Good talk. Quick question I wanted to find out from you, like, what's your approach for making third-party API keys available for like external developers that want to, like, you know, programmatically make changes into your infrastructure or your system?
Yeah, by default, I would look to providing API keys. So using API gateways option for API keys. Usually, sometimes you might want an extra layer of security. So you might want to ensure your users are going through Cognito. So if you know who your users are, you could potentially add them to a user pool of some sort, and this can help in terms of like authentication against your API. But in most cases, if you use API keys and a usage plan, you'll be able to identify who's made a request to your API and how many requests they've made.
Okay, cool. Now, the only reason why I asked is because I tried to do that the one time, but then I realized that AWS actually says that you shouldn't use the API keys for like external use, because then everybody will have access to all, like one usage plan has access to all your functions. But I think it's better to make to use a user pool or a Lambda with a custom IAM role.
Yeah, 100%. If your application has more secure requirements, I think a safe bet would always be to use Cognito, and then maybe your users would authenticate using Cognito, and then they'll just be provided a JWT token that gives them access to your API.
Cool. Yeah, most definitely.
Cool. Any more questions or experiences that people have faced with scaling serverless architectures, or any experiences at all with any of the services that we've spoken about?
I do have one. So, like you mainly talked about the REST API, but what about the HTTP API? I think it's better for costs, or like when would you use that one?
If I can remember that off the bat. So the difference between the REST API and HTTP API is in terms of some of the provisions that they give you. So can I remember this off the bat? What I can direct you to is the AWS resources on the different APIs and their specific characteristics that they have. For instance, if you want to use HTTPS and HTTP protocol, you might want to go for an HTTP API. And I know for REST APIs, you only support the secure connection, so you only have HTTPS. And I think that's just one of them, but there's several different cases. And it just depends on the requirements of your application.
Okay. Does anyone want to fill in the survey that I posted there in the chat? It's going to be the entry into the AWS credit lucky draw that we'll do in a few minutes. I think it doesn't look like anyone filled it in. Hey?
Just another question from my side, Tadiwa. I know Rian has his opinions because he's written a blog post about this before, but what's your approach for observability and monitoring, but doing it at like a cost-effective way? Because obviously using New Relic and Datadog, that's just like a no-go for like most teams, because it's just like, it's a massive budget commitment. So I'll be keen to hear your thoughts on that.
Yeah, so usually I'd go for CloudWatch if I'm using AWS Lambda, because that comes in the box. And you've also got the addition of X-Ray, which is pretty powerful, pretty cool. And X-Ray enables you to trace all your requests coming in from API gateway through to your Lambdas and to your database. It also helps you identify which parts of your system are not as performant, which enables you to sort of like double down on areas of like key performance areas. So X-Ray is pretty good as well if you don't have the provision of using other third-party applications like New Relic. Although I have nothing against New Relic, pretty good as well. Yeah, it's an option to use X-Ray and CloudWatch.
Okay, cool. So you prefer doing it Rian's way, like using stuff out the box and customizing it like to its core, essentially.
It depends. It depends with the needs of that particular application. So for some cases, there's some cool features that you'll find on perhaps like New Relic, but for most like cases that I've experienced myself, X-Ray and CloudWatch with good logging within your Lambda functions provide quite good logging and help you identify any nuances in your application.
Okay, no, cool. Thanks, man.
Like also just like my 2 cents, like something that I've seen is that if you are working at an enterprise company, they usually don't mind to burn money. So go for Datadog, especially if it's big teams, people that aren't serverless by nature, like coming from a more traditional role, then Datadog is very nice. But if your engineers are like very experienced in AWS, and then they know how to get around the console, go to the logs, jump between some windows, then CloudWatch is more than powerful enough that I've seen. Someone raised their hand. Do you want to unmute and ask a question?
Yeah, hi, Tadiwa. Excellent presentation, by the way. I have a question around the Lambda authorizer that you spoke of earlier on. Just, well, how practical is it given the limitations that exist with concurrency if you have many users trying to authenticate? I know obviously you mentioned the fact that you can cache results, which is useful, but then obviously with the issue with the code starts as well. Is it practical? Is it a thing where at scale you'd end up moving to something like Cognito and so on?
Yeah, I think first place would be Cognito for a case like that. With Lambda authorizers, they also use up a Lambda authorizer is just a Lambda. So it also uses up the concurrency that you have in your account. So that can potentially throttle some of your business logic Lambdas that are lying underneath. So if that one authorizer Lambda gets so many requests, it's going to use up the concurrency limits for your account, which might maybe lead you to having to make a request to AWS to increase your limits. That's a more complicated way to go. So Cognito is quite safe to use for auth if you don't have very stringent or very strict requirements for your application.
Thanks.
That's a good question.
Anyone else? Then let me share my screen. Thank you for filling in the survey. It seems like everyone just needed a bit of encouragement. These are the ones that filled it in today. Yeah. Yeah. Stick names. Game. Okay, I think I have 2 more credits giveaway, so we'll do 2 draws. Okay, and that is Kamogelo. So move your name and draw one. Francis, if I'm saying that correctly. Okay. I will get the credits. I first need to check if I do have some credits, and then I will send it to you via email because I do have your email now. Thank you very much. And I think that's mainly it. I'm going to stop recording as well. And then I also just want to thank